Kia ora tātou. Let's go through question 1 of the 2019 exam. So this is the first question. There will always be a few questions on naming and drawing organic compounds. So this one has just got 3 carbons. So it's got the base part of it is prop. And we need to recognize that this part of the compound is a carboxylic acid, and carboxylic acids are named with enoic acid at the end. So we're just going to call this propanoic acid. Propan-2-amine, so again we've got the prop part of it there, so we'll go 1, 2, 3, and then the 2-amine, so we've got the amino group coming off the second carbon, NH2, and then we just need to make sure that we fill in the hydrogens, otherwise it could be marked wrong. Once I've done this, and then the next one, we've got 2 functional groups. We've got a double bond. You might not be able to see it very well actually, but it is a double bond. We can tell because each carbon's got 4 bonds coming from it. It's not a triple bond. And we've also got the chlorine group. So we need to think about the priorities of naming compounds. So the alkene has a greater priority than the haloalkane. So anything that is going to change the end of the name. So an alkene changes something from ane to ene, so that's changing the end of the name. So that's going to take a greater priority than the chlorine, which changes the start of the name. So we're going to name this from the left-hand side. We're going to give the alkene the lowest possible number. So we go 1, 2, 3, 4, 5. So there's 5 carbons as well, so it's going to be 5 chloro, 5 chloro pent 1 ene. Okay, then 2, 3 dimethyl butane, so we've got bute, 1, 2, 3, 4, 2, 3, so off the second carbon we're going to have a methyl group, off the third carbon we're going to have a methyl group, and then we just fill in the rest. CH3. Getting lots of emails that are all coming through in this video. Alright, so that's naming those compounds. Great. Let's move on to drawing the structural isomers of C4H10O. So C4, let's start off with just a normal straight chain molecule. So we can put the OH group off the first carbon, and that's going to give us butan-1-ol. Sorry, just bear with me, going as quick as I can. Butan-1-ol. But we're not actually naming them, sorry. So that's butan-1-ol. We can also make it butan-2-ol. It's a good habit to name them because you might just be drawing something in a different way but actually end up with the same name. So by naming them and checking that their names are actually different, you are making sure that you're actually drawing different compounds. So that is another one, that's butan-2-ol. We'll classify them in a second. Classify the alcohols. Then we can, once we've exhausted all of the straight chains, then we can start to do a branch chain. So with this one, let's put the hydroxyl group off the first carbon. So this would be 2-methyl-propan-1-ol, and then we could do 2-methyl-propan-2-ol as well. So an OH group there and a carbon there. I'm not going to do the hydrogens there. So yeah, the type of alcohol, this carbon is bonded to one other carbon, so that's a primary alcohol. This carbon here is bonded to 2 other carbons, so that's a secondary alcohol. This carbon is bonded to one other carbon here, so that is a primary alcohol, and this carbon is bonded to 1, 2, 3 other carbons, so that's a tertiary alcohol. Done. Well done. So moving on quickly. So we've got 2 compounds here. Draw and name the geometric cis-trans isomers. So we need a double bond for a geometric isomer to be able to exist. So this one, which is an alkene, cannot exist as geometric isomers. So we're going to draw this one here. So we draw geometric isomers like this. Here we haven't, from this we don't show that as the hydrogen actually bonding off the carbon, so we need to draw it slightly differently when we're doing our cis-trans isomers. but we can just go HCH3. You might actually see this written as, instead of like that, it might be H3C, and it's just to exemplify that the bond is going to the carbon there, not to the hydrogen. So C, and then we need to do a trans isomer, CH3, HCH3. So draw and name the two. So we're going to be cis hyphen bute to ene, and then trans hyphen bute to ene. Nice work. All right. So the next question, explain why compound A exists as geometric cis-trans isomers while compound B does not. So there's two things that we need to include in our answer. One is that the double bond restricts rotation. And the next thing that we need to include is that each carbon on the double bond has different groups attached to it. So in our answer we'd just say that compound A has got a double bond, and it's also each carbon of the double bond has got different groups of atoms attached to it, so it's got a hydrogen and a methyl group, whereas because compound B does not have a double bond, it cannot form a geometric isomer. So any answer like that, check the answers to see the model answer. Okay, explain how acidified potassium permanganate solution can be used to distinguish between compounds A and B. So we've got an alkane which cannot be oxidized, and we've got an alkene which can be oxidized into a diol. So the type of reaction is oxidation, and because we're using potassium permanganate, we're going to go purple to colourless. Those are going to be our observations. So have a look at the oxidation reactions video that I've done if that's a little bit confusing for you. I think that's about all you need. Maybe, yeah, just saying that alkanes can't be oxidized. Alkene will be oxidized by potassium permanganate. Alright, compounds A and B will both react with bromine water. Compare and contrast these reactions by referring to the conditions required. So the conditions are for compound B, which was the alkane, we need UV light for it to react. The observations, we're going to observe the brown color of the bromine water going to colorless. So that's observations. The product formed. So for the alkane, we've got C2, 3, 4. So we've got those hydrogens all in there, and what's going to happen is one of the bromines from Br2 is going to make its way and replace one of the hydrogens from the alkane. So it could be that bromine could go anywhere. We could end up with one bromobutane, or we could end up with two bromobutane. So any of those would be fine. And then, what else? And the type of reaction. So for this one, for compound B, this is a substitution reaction. Substitution, so that's compound B. Compound A, have I got this the right way around? Compound A and B. Let's have a quick look. Yes, no. Yes, I do. And compound A is an alkene, so that's going to be a fast reaction, which doesn't require any particular conditions. The observations, we're going to see that the brown or orange Br2 is going to quickly decolorize. The products formed is going to be that from that double bond, there was a double bond there, that's going to then be replaced by two bromine atoms, and the type of reaction is addition. Alright, I was trying to keep it under 10 minutes, didn't manage to. I hope you've managed to find this alright. Just go look at the answer schedule if you need any more help, or send me a question. Thanks very much. Have a great day. See you later.